Howdy, y'all. Welcome to video lesson 5.2.5. We're going to wrap up our discussion of limits for chapter 5. In this video, this is your last video for chapter 5. And then we will do some closure in the next couple days and then take a test. We're going to work through number 94 first on page 256 in your book, but I have changed it slightly. I've taken away the graph that they gave us because we dealt with the piecewise functions in our last video. But we're going to talk about this function right here that I've written, f of x equals negative 2 over x plus 2. Okay, and I've given you the 6 parts of number 94 that they want you to find here. We're going to work through these in a little bit of a different order. Okay, and so we're going to talk through our strategies for how to find limits from equations. Okay, the best and easiest ways to do it, and the ways that we can go about doing that when the best and easiest way doesn't work. Okay, so what I'm going to start with in this case is I'm going to start with my positive and negative infinities because we have been dealing with those a little bit previously. So what I want you to always remember when you're finding a limit at infinity or negative infinity is I want us to be thinking 10 billion. I want us to be thinking 100 billion. Okay, I want us to be thinking of a gigantic number, or in the case of negative infinity, a gigantic negative number. Okay, that's what our x value is going to, the value that our variable x is going to take on. So we're going to start with a and f, and we're going to deal with these infinities here first. And we're going to start with negative infinity. So if I think of plugging negative 100 billion into this equation for x, the bottom of my fraction is going to be very close to negative 100 billion, right? It's going to be negative 99,999,999,998, basically negative 100 billion. So what I end up with is a negative very big number on the bottom of my fraction, okay? A negative big, a negative really gigantic. The top is a negative 2, but that's just a number, okay? And I want us to remember that every time we have just a number, we can think of it sort of like our 1 over situations, right? We wrote this down a few videos ago. 1 over big is equal to very tiny, right? Basically nothing. So when we see a negative 2, that's basically the same thing as a 1, okay? It's not that much bigger than 1. So we get basically the same idea here, okay? This value is 0. Okay, this value is 0. Now, it's important to note that this 0, as we're approaching negative infinity, okay, that 0 is coming from the positive side because my function is a negative 2 over a negative really big number, and a negative over another negative makes a positive. Okay, so this limit going towards 0 is coming from just a little bit positive and coming down to 0, okay, because it was negative over negative. The opposite is going to be true when we go here. Okay, so if we look at this limit now as x is approaching positive infinity, x approaching positive infinity is going to basically be exactly the same thing, right? If I think instead of negative 100 billion, if I think positive 100 billion, I should realize that the bottom of my fraction is not going to be negative, but it is still going to be something very, very big. Okay, so now it's a positive gigantic number instead of a negative gigantic number. So negative 2 divided by a gigantic positive number is going to be 0, right? Whenever we have just a number over something gigantic, it's going to be 0, okay, or really, really close to 0, and we're going to be approaching 0 as x approaches infinity. Now this 0 is actually coming from the negative side, right? So it's a little bit negative and it's getting closer and closer and closer to 0, coming up just a little bit because we have a negative 2 over a positive number, okay? And a negative 2 over a positive, negative over positive is negative. So these numbers, as we're getting close to 0, right? Remember, that's what this limit is telling me. I'm getting closer to 0. I'm getting closer to 0 from underneath, from the negative by just a little bit, okay? But this idea of plugging in a gigantic number for our infinities sort of leads me to the number one most useful tool for finding limits, okay? And it sort of is related to the continuity that we talked about yesterday, okay? Remember the third condition of continuity. We needed our y value to equal our two-sided limit, okay? And I'm going to tell you guys, most of the time, most of the functions that we deal with for almost every x value are going to be continuous, okay? Which means they're going to fit all three of those criteria from our last video, particularly number 3. And number 3 says that the y value of the function is the two-sided limit, okay? So if you need to find a limit, particularly a two-sided limit, okay? If you need to find a two-sided limit, what I need you to do is just plug the x value in. Plug the value for x that they want you to approach into the function, and 9 times out of 10, that's going to tell you the limit as you approach that x value, okay? So for example, if we work back to letter E in number 94, it says x approaches 2. So if x is approaching 2, and I plug that value into this function f of x, I get negative 2 over 2 plus 2, because I replaced the x with the 2. And negative 2 over 2 plus 2, well, that's negative 2 over 4, which is just a fraction, which can be reduced, okay? And when we have a function that's not a piecewise function, okay, not a piecewise function, if you plug the x value in and you get a number that's a number, it's just fine. Like in this case, we get a fraction, negative 1/2. That is going to equal your two-sided limit, okay? Because that basically means that we have a continuous function at that point, x equals 2. Okay, so when it's continuous, when you plug the x value in and it works out fine, that's going to be your two-sided limit, unless you have a piecewise function. Okay, and we'll talk about that a little bit later, way later on. Then we got to check both sides. We know that. So letter E, negative 1/2 is my two-sided limit as x approaches 2 in this case. All right. If I move then up to letter D, they want me to do basically the same thing, but they want me to do x approaching negative 2. Two-sided limit as x approaches negative 2. Again, number 1 strategy, and first thing I'm going to try is I'm going to plug negative 2 into this function. And it's going to end up being this. Negative 2 over negative 2 plus 2. That's what the bottom of the fraction becomes. Now, hopefully we're starting to see what the issue here is going to be. The bottom of my fraction is going to end up being a 0, right? It's negative 2 over 0. So 0 in the denominator of a fraction is bad news. We can't do this. This is not a value, right? This is undefined. So when you plug an x value in and you get something that is undefined, particularly something over 0, okay, then we have problems, okay? Then the strategy of plugging the x value into the function doesn't work, and we have to have a different one, okay? And generally our go-to strategy for that secondary strategy, if we can't plug a value in, is to look at the graph, okay? So I'm going to bring up for you a graphing calculator with my y equals, and I have plugged the function in, making sure that the bottom is in parentheses, x plus 2. Okay, so I'm going to put the function into my y equals, and now I'm going to go to window, which is right next to that y equals, and hopefully you notice that my x min and x max are negative 4 and 0. Now the reason that I did that is because I am focused, you guys, I am focused fully on this negative 2 right here. This is the x value they want me to approach, right? So I just went a little bit on either side of negative 2. I went down by a couple, I went up by a couple. Negative 4 to 0 should give me a decent window to see what's happening as I approach negative 2, all right? And then I made my y min and y max sort of normal, negative 10 to 10. And then my scales, x scales 1, y scales 1, the rest doesn't matter. So negative 4, 0, negative 10, 10, in terms of our window, is going to give us a good picture of this. The x values, like I said, are going to depend on what x value do they want you to approach. If I then go ahead and hit graph, we see this graph, right? Yours is probably going to take a second and do its little drawing thing or whatever. But we see this graph, and I want you to notice that right here in the middle is x equals negative 2. Okay, and you can figure that out by hitting these left and right arrows, right? There it's flashing. X equals negative 2 is right here. Okay, so I want you to think about what's happening as my function approaches negative 2, this particular x value, from the positive side. Okay, from the positive side, So from over here, if I work back towards -2 into the negative, we should see what we think is happening, right? Or what the little bug that we put on that function thinks is happening as we walk back towards -2. And then if we did the same thing coming from the negative side, coming from a little bit lower than -2, okay, we work up to -2, we should see what our function is doing in that regard as well. Now the question for letter E in 94, or sorry, letter D right here is, do both sides agree? Well, do both sides agree? No, they don't. So what do we say about the two-sided limit of a function when both sides don't agree? We say it does not exist. Okay, this does not exist. So letter D in number 94 does not exist because that two-sided limit, we don't have both sides agreeing with each other. Okay, we got them doing this kind of weird thing, right? So then letter B and C should make a little more sense because they want us to do one-sided limits. So they want us to come from the positive, right? From the positive, what's happening as we go to -2. From the negative, what's happening as we go towards -2, okay? So from the positive, from the negative, what's happening from each side. So if we go from the negative for letter B, from the negative side would be back here. If I go towards -2 from below, from the negative, say from -4, and I go on my function, what's happening to my function as I approach -2? Well, it's getting very, very big, right? It's going up. So from the negative, from below, I think my function's going to infinity, okay? And from above, I think if I come from above here, I think I'm going to -infinity. All right, so this one is -infinity. I'll squeeze that in there. -infinity for letter C, okay? So that's number 94. And like I said, it highlights our main two strategies for finding limits. Okay, our main two strategies. Strategy number 1, plug in the x value. Number 2, if you get something undefined, look at the graph. Okay, that's sort of our strategies for right now. There are other strategies that exist in the calculus world and so on. We may get to some of those in chapter 8. But for right now, this is what we're doing. So this works for finding a limit, I should say a two-sided limit of a function, not piecewise functions though. Okay, the piecewise functions, like I said, we've talked about before. We've been working on IXL on those things. And those we have some extra work we have to do, right? We have to look at the function. It's more so from a graph of a piecewise function that we're going to find our limits. But if it's not a piecewise function, this is my number 1 strategy. Plug in the x value. Doesn't work? That's okay. Look at the graph. All right? Now let's flip over to number 98. We're going to focus only in on parts B and C. Okay? Parts B and C. They give us this function here. 1 minus cosine of x over x. So really what they're looking for in the end here, you guys, is they want the limit of this function as x approaches 0. Okay, so as x approaches 0 for this function, they want to know what's going on here. Okay, what's going on? Well, again, let's go with our number 1 strategy. This is not a piecewise function. Let's just plug 0 in here and see what happens. Now, it's important to note, or it should be obvious, I guess, right away, that we're going to run into some trouble. Why? Well, because the bottom just says x, and I just told you I want x to go towards 0. So if I plug that in, the bottom's guaranteed going to be 0. Okay? It's the best 0 I've ever drawn in my entire life. Take a picture of that. The question is, what's happening to the top of the fraction? Okay, what's happening to the top of the fraction? Well, what is the cosine of 0? That's the real question here, right? What is the cosine of 0? Remember 0, if we think back to our unit circle, 0 is over here, right? Cosine is the x value. What is the cosine at 0? It's 1. Cosine of 0 is 1. So if I go 1 minus 1, that's 0 over 0, right? That's 0 over 0. So again, this is something that's undefined, but it's sort of a special undefined. Okay, I want you guys to keep in mind this right here, 0 over 0 is very, very special in the calculus world. Okay, in the calculus world, your whole life is going to change when you learn a rule about 0 over 0 limits. Okay, we're not dealing with that right now, though. Okay, and for right now, this didn't work out. We got something undefined. So what should we do? Well, we should look at the graph. Okay, so we're going to look at the graph of 1 minus cosine over x. So if I go back here and I go back here and I clear this out and I go now parentheses 1 minus cosine x, close parentheses again because now there's double, and then divide by x. That's my function, 1 minus cosine x, close parentheses, divided by x. Again, I'm worried about going around 0, right? I want to know what is my y value around 0. So I'm going to go ahead and make my x min be maybe -3 up to +3, just a little bit on either side. -3 is close to pi, so it sort of sounds like a cosine thing we might be doing, right? Now it is important before you click graph to click mode and make sure that you're in radian mode here, not degree mode. Okay, make sure you're in radian mode when you graph a cosine, because then otherwise degree is going to look real weird. So, all right, my window, if I go back here, y min, y max, -10, 10, I'm going to leave that until I see what the graph looks like. All right, so now I hit graph, and I see sort of what's going on here. Okay, it looks like maybe I don't need my y to be quite so tall. So if you want a better picture of what's going on, we can go y min maybe back to, let's say, -1 to 1, which makes a little more sense because we're talking about cosine here. So then if I graph, it sort of looks like the start of a cosine graph, right? It would, or sorry, the start of a sine graph actually. It would go up and come down and go up and maybe, you know, going the other way too. I don't know. But from this particular picture, I think we can see what our two-sided limit is as x approaches 0, right? So think again, okay, two-sided limit, I need both sides to think the same thing, right? I need coming from the positive side, I need to be thinking the same thing as coming from the negative side. So if we come from the positive side here and we work back towards x equals 0, where do I think the y value is going to be? It looks like it's going to be the origin. It looks like it's going to be 0, okay? Coming from the negative, same thing. Looks like it's going right towards the origin. So do both sides agree? Yes, both sides do agree. So I do have a two-sided limit, and I can go ahead and say the two-sided limit as x approaches 0 for this function is 0. Okay. Now, this is not always true when it's 0 over 0. So please don't get that in your head, that because it was 0 over 0, that's why this limit's 0. That's not true. Okay. Sometimes 0 over 0 ends up equaling 1. Sometimes it ends up equaling 0. Sometimes it ends up equaling something totally different. All right. So again, strategy number 2, if you can't plug it in and get something nice, look at the graph. Okay. Look at the graph. Now, last thing I want you to do is I have an extra practice problem here for you. It's not in your book. You can just call it extra practice in your notebook. And it's very similar to what we dealt with earlier, okay? I have 6 limits that I would like for you to find. And I want you to think really, really hard about plugging in x values, okay? Plugging in x values. Letter A, you should be able to just plug the x value in. Letters D and E, remember what we plug in when we see infinity and negative infinity. Letter F, I don't think is going to work out very well. And letters B and C are about the same function. And so we may have to look at the graph for that one as well. If you have any questions about any of these limits, please let me know. But these are sort of the things that I now expect you to be able to do in terms of finding limits. Okay? These are functions that I expect us to be able to find limits for. And yeah, they all should work out to be pretty nice. I think, yeah. Again, if you have questions, let me know, reach out to me, but I do expect to see these 6 limit answers in the bookwork that you submit for this video, all right? Like I said, if there's anything that you need, please reach out to me. Email, phone, Zoom office hours are all available. Otherwise, that's all I have for you. And we'll see you later.